In the diagram below, we have that the angle DCB is actually alpha and AC is H. Okay, so you can see that AC is H there, units, and ACB is the angle theta, and that can be seen clearly there. So we are gonna now answer question 7.2.1. Determine the size of the angle ACD in terms of alpha. So this is actually ACD, that one. And so clearly the angle ACD is equal to theta minus alpha. And what is the reason for that? Obviously it is just simply angle addition, but they did not really ask you to state the reason there. So if you look at 7.2.2, you need to prove that AD is that one. So to do that one, you need to work in triangle ACD, and if you do that, you observe other angles that are present in the triangle. So you're able to see that this one is theta minus alpha. That is the angle there. And now you then proceed. Moreover, this angle D1, you can see clearly is actually 90 degrees plus alpha. The exterior angle of a triangle equals the sum of the interior opposite angles. Okay, so that is very clear. And so we proceed then on the triangle ACD. We shall have therefore that AD over the trigonometric sine of the angle opposite, which is theta minus alpha, which is also equal to what else? You can see that you've been told that AC is H, so you're going to take AC over the sine of the angle opposite, which is exactly 90 degrees plus alpha. This, when you cross multiply, means AD is equal to, so you have AC, the sine of theta minus alpha, all divided by the sine of 90 degrees plus alpha, meaning AD is AC is what is H, the sine of theta minus alpha, all divided by, now the sine of 90 degrees plus is going to be in the second quadrant, making it through the cofunction change cosine alpha, and that gives us AD there. That is the answer to 7.2.2. Right, so we need to look at do 7.2.3, and they're saying now determine the length of AD if it is given that H is that, theta is that, and alpha is that. So that's straightforward. So in 7.2.3, you're going to be able to find the length of AD, which is what they want. So we've been given H, which is actually 17, into the trigonometric sine of the theta, which is 58 degrees minus 23 degrees, all divided by the cosine of alpha, which is 23 degrees. And this means AD can be determined over there. Okay, very easily. So one can use a calculator to actually determine that. All right, so you can use a calculator to determine exactly the length of AD there, and we proceed. Obviously, let me also determine that using a calculator here. All right, so if I use my calculator to actually determine the length, I'll be able to find that the length is as required. Just one second. So it is actually 17 times the trigonometric sine of 58 minus 23 degrees. Okay, this divided by the cosine of 23 degrees. Okay, and we're able to get the result, and the result is actually 10.5 10.59 units. Now the next thing we're going to find is the following. 7.2.4. Right, so in 7.2.4, like if you need to find the length, the area of triangle ADC, so this is A and this is D and this is C, you need to find the area of that triangle there. You already know the length of AD, for instance, it is actually 10.59 units, okay? And then now you can then, for instance, proceed. You already know the length of H, which is 17 units, right? And what else? You need to just find the size of one of the angles, in particular the length, the size of the included angles. Or if you know, for example, that the angle, this one is 90 degrees, the angle theta here is actually how many degrees? Is 58 degrees, and that is 90 degrees. So you have to say 180 minus to get this one. So that would be 180 degrees minus 180 degrees minus okay, minus 58 degrees minus 90 degrees. Okay, so subtract those other two angles. So let's just make sure what that works out to. So 180 minus 90 minus 58. So it's 32 degrees, this one. So this angle is actually 32 degrees. All right. So if this angle is 32 degrees, then you can easily be able to find the area of that triangle there. So the area of the triangle ADC is ACAD the sine of 32 degrees. So what is AC, for instance? Right, AC it's H, which is 17. AD, we already know, is 10.59 units times the sine of 32 degrees. So the area of triangle ADC, right, so you can find that one, which is square units. So that would be 0.5, which is 1/2 times 17 times 10.59 times the sine of 32. So 0.5 times 17 times 10.59 times the sine of 32, which is actually 47.70 units squared. Or you can say the area of triangle ADC is 47.70 square units. All right, and so we have answered that one. So just to recap quickly, so they asked us first to find the size of each of these angles. So for example, right, they asked us to find the size of ADC, ACD, excuse me. So we saw that the result is actually theta minus alpha. Right, we have proven that. The proof is there. The length of AD as required, so we found the length of AD to be 10.59 units. Right, the area of this one, so the area of triangle ADC, we found it clearly there to be actually 47.70 square units. And that is the result. Okay, so we've answered the question in full. Many thanks everybody for actually joining us. Okay, we've solved this lovely question, and many thanks everybody. A goodbye to you.